All right, deep dive time. Today, things are going to get kind of, I don't know, mind-bending. We're looking at this research paper all about fractal generative models.
Yeah, and it's super cool how they're bringing those like crazy intricate patterns you see in nature, like snowflakes, coastlines, and using that idea in AI.
Okay, so fractals inside AI, that's some next level stuff. But before we get lost in the matrix here, maybe back up a sec. Why fractals for AI in the first place? What's the advantage?
So the paper talks a lot about how the usual ways we build these AI models that can create stuff, generative models, they have trouble with things that are really complex.
Right, like if you wanted to make a super high-res image, going pixel by pixel, that'd be insane amounts of data.
Exactly. And that's where the fractal thing comes in. Instead of doing the whole thing at once, you break it down into smaller pieces, kind of like a divide and conquer strategy.
Oh, I get it. So it's like those Russian nesting dolls, but each one's a mini AI making part of the thing.
Exactly. And because of that, it's way more efficient. They actually found that making a 256 by 256 image was only twice as hard as a 64 by 64. Scaling is nuts.
Seriously, that's wild. Okay, so fractals sound cool in theory, but do these models actually work? Like, can they generate stuff that's actually good?
Yeah, they put them through the ringer, tested them on ImageNet, that's like the benchmark for image AI, and they got some seriously impressive results.
Okay, like what? Give me the highlights.
So they actually did better than some older models, this thing called estimating likelihood, basically how well the AI understands what it's supposed to create.
So it's not just spitting out random pixels. It's got some real comprehension going on.
Yeah, and for generating high-res images, they're up there with the big dogs like GANs and diffusion models. The quality is competitive.
Hold up, that's huge. This is a brand new approach, and it's already that good. Okay, color me impressed.
It's really exciting stuff. And what's even cooler is this is just the start. The paper hints at all sorts of potential uses beyond just images.
Ooh, all right, lay it on me. What else can we do with fractal models? Besides make pretty pictures, I mean, got to keep our listeners hooked.
Super complex and not like a simple sequence. The paper specifically mentions how it could be good for anything like that.
Okay, give me an example. Help me wrap my head around this.
So, like drug discovery, you're designing these intricate molecules, or even modeling parts of the brain, which has that kind of fractally structure itself.
Whoa, so we could be talking about designing life-saving drugs or figuring out the brain? That's some serious next level stuff.
Totally. It's a totally different way to think about AI that makes things not just improving what we have, but building it differently from the ground up.
Okay, my brain needs a minute to process all this, but let's dig into how these things actually work. Time to unpack the magic.
All right, let's break down that architecture for image generation. It's pretty elegant, though a bit complex. So picture this, it's like a whole chain of command, but for AI making images, right? They use this series of these autoregressive models, each handling like a different level of detail.
Oh, okay. One model's working on the big picture stuff where the shapes are, and then another one's all about the fine details, like a team of artists, each with their own thing.
Exactly. But here's where the fractal part gets really wild, right? Each of these autoregressive models is actually built from smaller, like self-similar, autoregressive modules.
Wait, so it's fractals all the way down. My brain's kind of melting trying to picture this.
Aha, yeah, it's a mind bender. But think it this way, instead of one giant model trying to do everything, you've got these smaller specialized models working together, in this really efficient way.
Okay, I'm starting to get it, I think. But how do they actually make this whole fractal system actually generate an image? It can't just be magic, right?
Well, there's definitely some algorithmic magic going on. It all starts with just a single pixel, right? The first autoregressive model predicts its color based on some initial conditions, could be a random seed or maybe a category label, something like that.
Oh, that's cool. So it's like a tiny seed that grows into a whole image. Kind of like those freckles in nature, starting small and building up all that complexity.
Exactly. Then the next cell in the chain takes that first pixel as input and predict that the colors of the pixels around it, right? And this just keeps cascading down that fractal hierarchy, each model adding more and more detail.
Whoa, it's like this chain reaction of pixel prediction. But how do they make sure all these different models are like playing nice and creating an image that actually makes sense? Wouldn't it just end up looking like a jumbled mess?
That's where they get really clever with how they use transformers.
Ah, transformers. Those are everywhere in AI these days. We did a whole deep dive on those a while back. They were blowing everyone's minds with how good they are at understanding language, right?
Exactly. And now they're proving themselves in the visual world too. These transformers are key to making sure all those individual pixels actually fit together and, make a whole image. They can actually see the bigger picture even when they're focused on this small section.
Makes sense. The pixels aren't words, right? How do they adapt these language-focused transformers to work with images?
So they kind of treat the image as a sequence of, patches, kind of like how a sentence is a sequence of words. each patch becomes like a mini image that the transformer can process.
Ah, so it's like they're teaching AI to read images. That's pretty clever.
It is, right. And by breaking the image down like that, those transformers can really capture those complex relationships between different parts of the image.
Okay, so we've got autoregressive models, fractals, and now transformers, all in the mix. Sounds like a recipe for some serious AI awesomeness. But I'm betting there are some secret ingredients they added in to make these models really shine.
You bet. They didn't just stop at the basic architecture, they did some really optimizations to make them both more efficient and improve the quality of what they make.
Ooh, all right, spill the beans. What kind of fine-tuning did they do to these fractal models?
So one of the big things is how they scaled the complexity of the models across those different fractal levels. They realized that as you go deeper into the hierarchy, you're dealing with smaller and smaller image patches. You don't need as much computational power at that level.
That makes sense. If you already know the colors of the pixels around a particular pixel, figuring out what that pixel should be shouldn't require like a super-powered model, right?
Exactly. So they kind of strategically reduce the complexity at those lower levels, keep things lean and mean, but still get amazing results.
Ah, like a pyramid scheme, but in a good way. The most powerful models at the top, and then these increasingly efficient ones supporting it all underneath.
Perfect analogy. And that structure is actually what lets them get to those impressive 256 by 256 resolutions without needing a supercomputer.
Smart. Okay, but did they do anything specific to make the quality of the images better? After all, we want AI art that's more than just a blurry mess, right?
Oh, absolutely. They brought in some techniques that are already popular for making good images, but with their own like fractal twist.
All right, I'm intrigued. Always down for some AI art appreciation.
So one thing they use is called classifier-free guidance, right? It's kind of like giving the model some creative direction, a little nudge to help it make images with certain characteristics.
So instead of just saying make an image, you could say make an image of a cat wearing a hat, and it would be more likely to actually make something that looks like that.
Exactly. And the cool part is they don't need a separate model to do this. The information about what you want is already in the main model itself.
Slick. So how do they pull that off?
It's a bit technical, but they basically train the model by sometimes giving it incomplete information, like a category label, but without the actual image.
So it's like a pop quiz without the answer key. That's got to make it think outside the box.
Haha, yeah. It learns to generalize from what it has seen and figure out how to make something that fits the description, even without a visual reference.
That's super clever. So it's like giving the model a little nudge in the right direction, helping it focus its creative energy.
Exactly. And they found this really helped make the images better overall, more coherent and higher quality.
Okay, so they've got efficiency, quality control. What else is up their sleeve?
Well, they also throw in some temperature scaling just to add some spice to the mix.
Temperature scaling. Sounds like we're cooking up AI art in a high-tech oven now. What does that even mean?
It's all about controlling how random the image generation process is, basically.
Wait, random. I thought we wanted the AI to make stuff that looks realistic and intentional. Why make it random?
Because a little randomness can actually be good, right? It stops the model from getting stuck, making the same kind of images over and over.
So it's about adding some unpredictability, a little touch of chaos to make things more interesting.
Exactly. Like the saying, a little spice makes everything nice. By tweaking this temperature, they can control how much variety they want to see in the images.
Got it. Okay, so efficiency, quality control, a dash of randomness. Sounds like they've thought of everything. Sure, there are some challenges, right? Even the best AI isn't perfect.
True, there's always room for improvement. One thing they point out is that these models could get better at making a wider variety of images.
So even though they can make super realistic images of, say, a cat, they might not be as good at coming up with something totally new and unexpected. Like they could paint a photorealistic cat wearing a hat, but maybe not a cat wearing a hat made of cheese.
Haha, yeah, that's a good way to put it. It's like they're still playing within the boundaries of what they were trained on, not quite ready to be like Guy Picasso's breaking all the rules.
Well, hey, every artist has to start somewhere. But even if they're not making avant-garde masterpieces yet, these fractal models are a huge step forward.
Oh, for sure. It's a fresh perspective on how to build these models, and the results are really promising. Can't wait to see where this goes.
Me too. Already imagining all the wild things this could be used for. But for now, let's bring things down to earth a bit and talk about how this could actually be used in the real world. Because cool as they are, these aren't just theoretical toys. They've got real potential to change things.
Absolutely. Talked about drug discovery and brain modeling, but there's a whole universe of possibilities out there.
Start with something a little more everyday. What about image editing? Think Photoshop, but on steroids, haha. Could these models be used for things like retouching photos or creating special effects?
Definitely, yeah. In fact, the paper talks about how good they are at what's called conditional image generation, basically making images based on specific input or conditions.
So it's not just making random stuff. They can take directions and make something that meets specific criteria.
Precisely. Like imagine you have a photo with something distracting in the background, like a random person photobombing your perfect shot. You could use one of these models to just like seamlessly fill in that area with something that matches the rest of the scene.
Haha, no more awkward X's lurking in our vacation photos. Sign me up.
Right. Or think about outpainting, where you extend the boundaries of an existing image. Like if you have a panorama photo, but you wish it showed even more of that landscape, a fractal model could just add more to the scene.
That would be incredible for landscape photographers. It's like having an AI that can paint in those extra mountains and forests.
They even show how you can do uncropping, basically reconstructing a bigger image from a cropped version.
Hold up, wait, that sounds like magic. How can you create information that wasn't even there to begin with? Are we bending the laws of physics or something?
Haha, not quite. It's not about making stuff up out of thin air. It's more about using the information that's already there in the image and making educated guesses about what might have been outside the frame.
So it's like an AI detective, piecing together the missing clues to solve the case of the missing image.
Haha, I like that. And because these models are so good at seeing those long-range dependencies in the image, they can actually make some surprisingly accurate predictions. Not always perfect, but still pretty impressive.
Okay, so they can fix, extend, even uncrop images. That's wild. But can they also go full on and make totally new images from scratch, like those AI art generators that have been popping up?
Oh yeah, for sure. Remember they tested these on ImageNet, which is like this giant database of tons of images.
So they've seen a lot of different styles, different subjects, basically been to AI art school. Haha.
Exactly. And all that training means they can make new images that are kind of similar in style and content to the things they've already seen, but with their own little twists.
So they can make images that look realistic, but they can also get all artsy and make more abstract or stylized images. Like they could paint a portrait in the style of Van Gogh or create some surreal dreamscape like Dali.
Yeah, totally. It all comes down to the input conditions and the parameters you use to control the generation process, right? It's like giving an artist different tools and inspiration and seeing what they come up with.
Okay, so they're versatile little image wizards, but let's not forget about those other mind-blowing applications we talked about earlier. You brought up drug discovery, which honestly sounds straight out of a sci-fi movie to me. Can you break that down and get more? How could these models actually help create new medicines?
Okay, so imagine you're scientists trying to design a new drug. You need to find a molecule that has just the right shape and chemical properties to, interact with a specific target in the body, like a protein, and hopefully treat some kind of disease.
That sounds incredibly complex. Like finding a needle in a haystack, but the haystack is made of
It
molecules.
is a huge challenge, yeah. But that's where fractal generative models could be a game changer. They could be trained on these massive data sets of existing molecules and their properties and learn to understand those really complex relationships between structure and function.
So it's like giving these AI models a crash in chemistry, but on a massive scale.
Exactly. And once they've learned all that, they could then be used to generate new molecules that are predicted to have the right characteristics you're looking for. It's like having an AI chemist that can sift through billions of possibilities and say, hey, these ones look promising for making new drugs.
That's incredible. It could totally revolutionize how we discover and develop new medicines. We could find cures for diseases that have been around forever, or even make personalized medicine, tailored to each person's unique genetic.
Yeah, the possibilities in medicine are really exciting. And remember, we also talked about the potential for brain, too.
Oh yeah, that's right. That one really got my neurons firing. Using AI to understand the most complex organ in our bodies, that's just mind-blowing.
It is, right? And it seemed like a crazy idea, but remember, the brain itself has this kind of fractal organization.
You mean those repeating patterns at different scales, right?
Exactly. From the connections between individual neurons to those large-scale networks of brain regions, there's this hierarchical structure that resembles a fractal. And the researchers behind this paper think that fractal models could be, the key to understanding how the brain really works.
So we could actually create like digital twins of the brain, simulated models that could help us understand how it works, how to diagnose and treat diseases, maybe even design new AI based on the brain itself.
It's still early days, but the potential is huge. We could be on the verge of a whole new era in neuroscience, one where AI and the human brain are working together to, crack the code of consciousness.
Okay, you officially blew my mind. We've gone from fixing vacation photos to simulating consciousness. It's amazing to think that this one paper has sparked so many different ideas.
It really shows the power of this research, how it's pushing the boundaries of what we thought was possible with AI. And it also highlights how important it is to look to nature for inspiration.
Couldn't agree more. Nature has been perfecting its designs for billions of years. It's about time we started paying attention.
For sure. And who knows what other secrets are hidden in those patterns of the natural world, just waiting to be discovered and used to create even more incredible AI.
That's a thought I'll be chewing on for a while. But for now, let's maybe talk about the potential downsides of this tech too. Powerful as it is, we need to be aware of the risks as well.
Yeah, absolutely. With great power comes great responsibility, right? And like any powerful tool, there are always potential pitfalls we need to think about.
So what are some of the things we need to be careful about? These fractal models get more sophisticated and, more people start using them. What are the potential dark sides of this AI revolution?
Well, one concern is that they could be misused, especially when it comes to making images and videos. As these models get better, they could be used to create really realistic fakes, like deep fakes that are almost impossible to tell apart from real footage.
Deepfakes are scary stuff. Imagine someone using AI to create fake evidence of something that never actually happened. That's a whole new level of misinformation and stuff, right?
Exactly. And it's not just limited to politics. This could be used for all kinds of bad stuff, creating fake identities to scam people online, spreading harmful rumors, really messing with people's reputations.
Okay, so we need to be vigilant about how these models could be used for bad stuff. What about jobs? Could these AI models actually replace human artists and designers? Are we all going to be out of work, replaced by robot Picassos? Haha.
That's a real concern and something we definitely need to be thinking about. As AI gets better at making creative stuff, some jobs are going to be impacted, for sure.
It's like that old saying, the robots are coming for our jobs. But seriously, how do we prepare for a future where AI might be able to do some of the things that humans have always done?
Well, I think it has to be all doom and gloom. It's not about robots versus humans. It's about figuring out how we can adapt and work alongside these technologies, right?
So it's not about being replaced. It's about finding new ways to work together, combine human strengths with what AI can do, right?
Exactly. Imagine a graphic designer using these models to generate like different versions of a logo, and then they can focus on the more strategic parts of their work, or musicians collaborating with AI to create new melodies and explore new sonic possibilities, things they might never have come up with on their own.
That's a much more optimistic way to look at it. It's like having an AI creative partner, right? Augmenting our own abilities and pushing the boundaries of what we can make.
And remember, AI still doesn't have that human touch, that spark of originality and emotion that makes truly great art so powerful, right?
Totally. No matter how advanced AI gets, it's not going to be able to fully understand and replicate the human experience anytime soon. At least I hope not.
Right. So it's not about being afraid of the machines taking over. It's about embracing the potential for collaboration and using these new tools to make ourselves more creative.
Well said. It's a reminder that AI isn't just a tech problem, it's a human problem too. We talk openly and honestly about the ethical stuff and work together to make sure these powerful tools are used for good.
Couldn't agree more. And I think these fractal models, with their elegance and efficiency, they really could be a force for good in the world. But it's on us to guide them in the right direction, right? We're the ones making and using these tools.
I'm feeling super inspired by this conversation, but also a bit humbled. We've gone from the beauty of fractals to the power of AI, and it's clear this stuff is going to change our world in some big ways.
It really is a fascinating time to be alive, and I think we're just scratching the surface of what's possible.
I can't wait to see where this all go. But for now, let's maybe get even more technical dig in specifics of this research because as much as I love big picture thinking, I'm also a bit of a data nerd, gotta admit it.
Sounds good to me. Let's take a closer look at some of the experiments they did and what they found. Time to geek out.
Hit me with those juicy details.
Okay, so first off, they looked at something called likelihood estimation. Basically, how well the model captures the underlying probability, like the essence of the data it was trained on.
So it's a way of testing if it actually understands the data. Like if you trained it on pictures of cats, could it accurately predict what a new cat photo would look like, even if it's never seen that cat before?
Exactly. And their models, especially the one with this bidirectional transformer architecture, did better than a bunch of other cutting edge models at this task.
So they're not just good at spitting out pixels, they're actually learning something deep about the data, right? Like what makes a cat a cat? in a mountain.
Yeah, and that's one of the reasons why they're so good at making high quality images. It's not just about random guesses, they're building a probabilistic model of what they see.
Okay, that's pretty mind-blowing. But let's get back to image quality. How did they actually measure that, and how did their models do compared to the competition?
They used a bunch of different metrics, including this thing called the Frechet inception distance, or FID. Then there's inception score, I, precision. Recall all these ways of judging how good and diverse the images are.
So it's not just whether the images look good, but also about how well they actually match the statistical properties of real photos, right?
Right, and they found their models, especially the bigger ones, got some really good scores, particularly on inception score and precision.
Which means they're making images that are both realistic and detailed.
Yep, and what's really cool is they saw this positive trend. Basically, as the models got bigger, the images got better.
So bigger's better in this case.
Seems like it, and unlike some other models that use tokenizers, which can introduce errors, fractal generative models might be able to scale up even further without hitting a limit on how good the images are.
That's exciting. Imagine how much better the images could get as these models keep evolving.
Totally. I think this really opens up new possibilities for making amazing images with this fractal approach. It's a totally new way of thinking about generative models.
Okay, so they're image generation rock stars, that's clear. But what about those other things we talked about, like using them for drug discovery or brain modeling, any experiments on that front?
Not in this paper, no. Remember, this research is still pretty new. It's more about laying the foundation.
So they planted the seed and now it's up to other researchers to, water it and see what grows.
Exactly. This showed that this fractal approach can work, and now it's up to the rest of the AI world to see what we can build with it.
I have a feeling we'll be seeing a lot more research on this in the next few years.
Oh, for sure. This paper has got everyone in AI pretty excited. I think it's just the start of something big.
All right, folks, before we wrap things up here, I just got to say the pure brilliance of this research is amazing. Who would have thought that fractals, these mathematical things that have fascinated people for centuries, would be the key to unlocking such amazing AI capabilities?
It just goes to show, the power of thinking outside the box, bringing together ideas from totally different fields to make something truly groundbreaking.
And it's a good reminder that inspiration can come from anywhere. You know, sometimes the answers to our biggest questions are right in front of us, just waiting for us to connect the dots.
Totally. Who knows what other secrets nature's got tucked away that we can use to build better, more powerful AI?
That's a question for another deep dive, maybe one where we explore that internet of biomimicry and AI. But for now, let's give a round of applause to the researchers who dared to think differently and really push the limits of what's possible with AI.
Absolutely. Can't wait to see what they do next.
Me too. And to all our listeners out there, keep exploring, keep asking questions, and keep that sense of wonder. Who knows, maybe you'll be the one to make the next big breakthrough in AI.
Until next time. One thing that really got me thinking from this paper is like, what even is creativity? It makes you question the whole idea.
Ooh, getting all philosophical on me. Haha. I'm always up for a good existential debate. What about this research has you pondering the meaning of creativity?
Well, we tend to think of creativity as this like uniquely human thing, right? Something that sets us apart from machines.
Totally. That spark of inspiration, the ability to come up with something new, something original that's like our special sauce. Now, the human. Hey there. Want to share your thoughts on this?
Hey, yes. Regarding to the creativity, can we jump to the common sense knowledge of the fractal?
Oh, you want to connect freckles with creativity. Let's jump into that.
Yeah, that's a great question because this is a novel idea.
Okay, so how does fractal knowledge help us understand AI creativity?
Well, understanding fractals gives us a framework. It helps us see how AI can generate complexity from simple rules.
Think of those self-repeating patterns, but in algorithms.
Exactly. It's not just copying us, it's actually coming up with its own stuff.
So you're saying it's not just random noise, but things that are creative.
Yes, it's actually things that surprise even the people who built it.
So it's creativity stemming from how a model interacts.
It comes from the data, algorithms, and the model structure.
That's a really interesting point, and it makes you rethink creativity.
It's not just about a human brain, but any complex system.
So it explores new possibilities and makes unexpected connections.
Right, and AI is getting really good at that.
It's kind of exciting, right? And we can make you rethink, makes us special.
We can now open up all these possibilities working together.
I agree. Imagine artists and AI working side by side.
Each one brings something unique to the, right?
That's a cool thought. We get a blend of organic and artificial creativity.
Yes, we could be entering a whole new era of art.
AI could help us push the boundaries even further.
Totally. Imagine art that reacts to your emotions.
Or music that changes in real time based on how the audience feels.
It's like we're giving each other superpowers.
Yes, we're amplifying our creativity by working together.
Exactly. Who knows what incredible things we could make together?
We could be creating things neither humans nor AI could do alone.
I think that's a perfect way to wrap things up.
This is the power of AI. It's a team effort.
It's about humans and machines teaming up to create something better.
Yes, it's something that reflects the best of both worlds.
Couldn't have said it better myself.
These fractal models show us how this could actually work.
To our listeners, keep exploring and asking those big questions.
Never lose your sense of wonder.
Maybe you'll make the next big breakthrough.
Keep the questions coming.
Stay curious, everyone. See you next time.
We hope that we have inspired you today, and thanks for listening in.